Welcome back to this eighth module of our review before Calculus 1. We're leaving behind the world of algebra to enter functions for the next three modules. So, a pretty important notion in calculus. What is a function? It's definitely a connection that exists between two variables, usually x and y, in the form of y equals f of x, which actually reads y is a function of x. We're going to be mostly concerned with the domain of a function. What's the domain of a function? It's simply all the values of x that can be replaced inside the function to produce a value of y. So basically, two cases will capture our attention in this module. Namely, if you have the square root of a function, or for that matter, a fourth root or a sixth root or any even root, you will actually want the inside of the root to be positive, simply because the root of a negative number does not exist in the real number system. The other things we want to take a look at is when we are dividing by a function, we do not want this function to be 0, simply because anything like 1 over 0 in mathematics is not defined. So these are the two things we have to be aware of. Don't let the inside of a square root be negative, and don't have the denominator of a function be equal to 0. Taking a look at this example here, I think I have both situations in the same problem. I have a root and I have an inside, and that inside is also in the denominator. So 2 minus 5x has got to be greater than 0, and it can't be greater than or equal to 0, because if this guy were 0, then this would actually be 3 over 0, which does not exist. So I can't have the denominator be 0. That's the only restriction that I need to find the domain of my function. So solving this is simple enough. Bring that to the other side. Divide both sides by 5. That's, of course, the same thing as x less than 2/5. And that's the domain of the function, which is best represented this way. Other people would like to say, let's have a real line, let's have 2/5 here, let's have an open dot because 2/5 is not included, and then let us shade that real line on the left because, well, we want to be less than 2/5. That's another way to express the domain of the function, but this is a more efficient way of stating what we want to know about the domain of the function. Another important feature regarding functions is to be able to evaluate functions at a given point. So if I want to know what f of a is, it will simply imply to replace all the values of x by a in the function. For example, f of minus 1 in the function 2x plus 1 over x minus 3 simply means let us replace all of the x's in the function by the required value, in this case, -1. So that's just minus 2 plus 1 over minus 4. It's minus 1 over minus 4. It's just 1/4. This, of course, means that the point minus 1 comma 1/4 is a point on the function itself. Okay, what about f of 3? Well, that's kind of, pretty much the same deal. We want to replace x, this time not by -1, but by 3, with the little difference that this time around we're going to get 7 over 0, and then we can divide by 0, so f of 3 does not exist. There is no y value for this function when x is actually equal to 3. Well, in the c part, we want f of w. Well, this is exactly the same strategy as finding f of 3, except that it's not 3, it's w. So I'm going to basically do exactly what I've done in the first two problems. Instead of replacing by a number, I'll replace my x with a letter. So I'm going to get here w minus 3. And what I get is not very eventful, but it is what it is. It's 2w plus 1 over w minus 3. Now, I want f of, yet again, another quantity called x plus h. So if we call this our w, we're really just doing again the same thing. So 2 times, instead of w, which I had before, I'm going to put in x plus h. It's always about replacing x with what you want the function to be. So you want f of x plus h. Well, you replace everything by x plus h, all the x's by x plus h. So downstairs, x plus h minus 3. And that simply gives us 2x plus 2h plus 1 all over x plus h minus 3. Not very pretty, but quite exact. Now, we will actually want, in the e part, we will want to calculate f of x plus h minus f of x. Well, f of x plus h is what we just calculated previously in the d part. So instead of redoing the whole thing, instead of reinventing the wheel, I'm just going to use what we've done. So I'm rewriting f of x plus h the way we had it in the d part. And now I am going to say minus f of x. What is f of x? It's 2x plus 1 that was given at the beginning over x minus 3. I will definitely want to simplify this, and that is definitely going to require what? Well, if you answered common denominator, you're perfectly right, because this is the way we know how to subtract two fractions. So brace yourself. There's going to be a lot of algebra in here. So crisscross 2x plus 2h plus 1 times x minus 3 minus 2x plus 1 times x plus h minus 3. So all again over x plus h minus 3 and x minus 3. Okay, now we're going to have to open these brackets. So, foiling out, 2x squared minus 6x plus 2xh minus 6h plus x minus 3. The second bracket, we do the same thing, so 2x squared plus 2xh minus 6x plus x plus h minus 3. So we're going to do what now? What would you do? Would you bring the negative side inside the bracket to see if there are cancellations? I think it's a good idea. So we're going to leave the denominator alone, and we're simply going to open up these brackets. So 2x squared minus 6x plus x is minus 5x plus 2xh minus 6h minus 3. And then minus 2x squared. Once again here, this is minus 2xh, and those two guys, that's minus 6x plus x, that's minus 5x. But there's a minus in front, so it's plus 5x minus h plus 3. Oof, that was some like major work. Now, reaping the rewards, cancellations galore. 2x squared minus 2x squared. 2xh minus 2xh minus 5x plus 5x minus 3 plus 3. Holy Moses, what is left? Minus 6h minus 1h, that would be minus 7h. all over this denominator that I will not expand because nothing much is going to come of it in terms of simplifications. Ladies and gents, this is f of x plus h minus f of x. And now to complete this problem, f of x plus h minus f of x, this is what we have just done in the e part. So what is that equal to? That's the e part, minus 7h over x plus h minus 3, x minus 3. And we want to divide this by h. This is what we want to do. So the division by h, as we all know so well, is multiplication by the reciprocal. So x plus h minus 3, x minus 3. And the reciprocal of h over 1 is 1 over h. Ciao, ciao. Final answer to this problem is minus 7 over x plus h minus 3, x minus 3. And that's that. Okay, again, very calculus related problem. So one last example, bringing it together what we've reviewed today. New function, root of x plus 3. What's the domain? Facile. The inside of the root is x plus 3. You want that to be greater than or equal to 0. It can be 0 here because the x plus 3 is in the numerator, not in the denominator. So that was short, that was quick, the way we like it. This is the domain, x is greater than or equal to negative 3. F of 1 is the root of 1 plus 3, that's the root of 4, that's 2. Not plus or minus 2, just 2. What is f of x plus h? Well, I keep my function here so I can see it. F of x plus h is the root of, this was x plus 3. So now, in this bracket, instead of x, I am going to put x plus h. Say 2. What is the f of x plus h minus f of x expression? Well, it's root of x plus h plus 3. This is what we have found in the previous part. And we want to go minus f of x, which is just root of x plus 3. Okay, so now what I would like to have is f of x plus h minus f of x over h. So basically now this is the answer to the d part. So this is root of x plus h plus 3 minus the root of x plus 3. This goes over h. Question, can we simplify this? Is there a way to simplify this expression? And the answer is yes, if you are thinking along the lines of the conjugate. Yes. So we are going to multiply top and bottom by the conjugate of the numerator, x plus h plus 3 plus the root of x plus 3, and I'll do the very same thing in the bottom. Okay, so what's that equal to? Well, the top, the numerator, have mutual conjugates, so this is the part that we expand. That means that the bottom we do not expand. That's going to stay h times the root of x plus h plus 3 plus the root of x plus 3, no change. Now let's FOIL this out. This times this is x plus h plus 3. Now this times this minus this times that, the two middle terms will go away. I can write them up, but they basically will cancel. Plus 3 root of x plus 3 minus the very same thing, x plus h plus 3 root of x plus 3. Now, what really matters is the last part, root of x plus 3 times root of x plus 3 with a minus, that's minus x plus 3. My middle terms are gone, so I am left with x plus h plus 3. And bringing in the negative inside this bracket, I find minus x minus 3 all over this guy. No change in the denominator. So you can see that doing this conjugate thingy will allow me one extra cancellation. Here in the numerator, plus x minus x plus 3 minus 3, as you can see, I am left with h over h bracket with the rest of the denominator. Ha! So these h's are about to go. And the final answer to this problem is simply 1 over the root of x plus h plus 3 plus the root of x plus 3. That is what we were looking for in this situation. Okay, one last. F of x minus f of 1 over x minus 1. What's f of x? Root of x plus 3. What's f of 1? Root of 1 plus 3 over x minus 1. What is that? That is the root of x plus 3. 1 plus 3 is 4. Root of 4 is 2. So we have that. And I ask once again, is there a way to simplify this? And the answer is just like in the previous problem. The answer is yes, provided we multiply top and bottom by the conjugate. So root of x plus 3 plus 2. Root of x plus 3 plus 2, and that guy was over x minus 1. Good. Expanding the numerator, leaving the denominator as is. Don't expand the denominator. That would be a mistake. Why? Well, you're about to see why in 1 second. Root of x plus 3 times root of x plus 3, that is x plus 3. Plus 2 times the root, minus 2 times the root, the usual thing, the middle terms cancel out, and minus 2 times plus 2 is minus 4. So this is gone. What am I left here? What's plus 3 minus 4? It's minus 1. Haha, now you know why we did not expand the denominator, because it would have taken away any chance that I would have had to do any more cancellations, and now I can get rid of that. And the final answer to this problem is 1 over the root of x plus 3 plus 2. And that concludes